And now it's bringing.
Find it back here. There's some All right, good afternoon, everybody. This is now 6:01. We're about to begin. All right, what I'm gonna do in this live, what we're gonna do is I'm gonna be looking at questions from 10 and come around, right? Sort of just getting us to get some more practice on the more difficult ones first. All right, because we have been doing the ones from number 1 coming along most times. So today I'm going to look at like vector and matrices first, then I go trigonometry, geometry, and so on. All right. All right. So so this is a number 10 question, and all number 10 questions are titled vectors and matrices. So let's go. It says here the transformation T is defined by the matrix T, which is equal to 2, -1, 2, 0. All right. Now it says here a point A, I'm right here, is mapped onto the point A prime. And here are the coordinates under T. This is T. Find the value of A and B. All you're required here to do is to simply operate on the point A with the matrix for the transformation, and whatever result you get would have been that for A and B. Normally you put that transformational matrix to the left, so you'll have 2, -1, 2, 0. This is transformation T. And the point A must be here, and you're going to write it in a column form. And then you operate on it, regular multiplication. And it's going to give us the result for A prime. So we're talking about row by column. Here are my rows. That's row 1, row 2. So if I should identify them quickly, row 1, row 2, and I only have 1 column. Here it is, right? So that's just column 1. So row 1 times column 1, 2 times -2 plus -1 times 3. So 2 times -2 plus -1 times 3. Underneath that, row 2, column 1, 2 times -2 plus 0 times 3. Let's see what we have. So we're talking about 2 times -2 at the top, that's -4. And then we have a -3. Underneath, we have -4 plus 0, right? Finally, I'm getting -7. Oh, I said 4, but I wrote 2 here. Let me write it. This is a 4, right? Yes, I said 4. All right, so that's -4 here. There we go. All right, so when that transformation T work on the point, that's the result. So that's what you do. You're expected to do that. No stress, take your time and work. So a transformation and matrix must go to the left of the point, please, all the time. So you write it first. So follow the order and you see what's going on. That's an easy 2 marks, and we're at question 10. Now, look what we did. What we just did was that we had a point, we operated on it, and we got the image. All right? So you're talking about, like, for example, this is our object, and the result, after we transform it, we got that. Now, look what they want from you. Determine the transformation matrix that maps A prime to A. Anybody want to quickly just suggest what it is that you think that they want from you here? What matrix could have done this? Remember, we did A to A prime, but they want you to find a matrix that will move A prime to A. Anybody? Going once, going twice. What do you think?
Identity matrix.
You're thinking, but what you need to do is to do the inverse. All right? It's just the inverse. Because if there's a matrix, the inverse, yes. Because if the matrix move me from A to A prime, and I want to move from A prime back to A, I'm going to do the reverse. So it's the inverse that I'm going to have to do of the matrix. So in other words, this question is testing to see if you could understand that if I'm going to move from my image back to the object, I have to do the inverse of what took me there. So in this context, we're going to have to find the inverse of T. T inverse is 1 over the determinant of T times the adjoint T. We want to relate to those ideas. Now let us take a quick look at the matrix again. All right, so the matrix was, let me write it back. I think the matrix was 2, hold on. Oh, let me identify these. You see, we forgot to identify these. Let us just write them back quickly. A is -7, B is -4. I'm just saying, I forgot to write them back exactly what, no, just write back what they asked, right? Good. All right, so the matrix is actually, so here's the matrix T. It's 2, -1, 2, 0. We're gonna do the determinant of that, and please be reminded that it's the product of the main diagonal. So let's find the determinant of T right here. So it's gonna be 2 times 0, and you're gonna minus this other diagonal, which is gonna be 2 times -1. So what we're looking at here is 0 plus 2, which is 2. Go ahead.
You could put the -1 first also.
Yes, yes,
okay.
yes. Just make sure that you don't mix it up with this. This must be there. That's the that's a part of the formula. But yes, anyone could go first.
All right.
So the determinant of the matrix T is 2. Now let us just write the adjoint right there. So the adjoint T is simply to switch the elements on the main. So the 0 will come here and the 2 will come here. And then we're gonna change the sign on the other diagonal, which is this one. So the -1 becomes positive and the +2 becomes negative. So there comes the adjoint. So it is 0, 1, -2, 2. Then now fit everything together. Come back here. 1 over my determinant. And then I'm gonna put my adjoint here. And then you wanna just slide it inside, so you'll end up with a 0 here, 1 over 2 here. You get -2 over 2. I'm gonna simplify that. You're gonna get 2 over 2. Finally, you could break it down. 0, half, -1, 1. Take a look at it. 0, half, -1, 1. So that matrix would have done the reverse for you. So what we want to take away from this is, if one matrix takes me from my object to my image, then if I'm going to move from the image to the object, it must be the inverse of that matrix. And the inverse of the matrix is done the way in which you know an inverse is done. All right. Let's continue working. Continue working. Now, this question reads, it says, another transformation P is defined by the matrix. So P is 0, 1, 1, negative 2. So that's another transformation. The question says, find the single 2 by 2 matrix that represents the combined transformation of T followed by P. Now, whenever you get anything like this, where we say T followed by P, the first is T, the second is P. Remember, you're gonna have to put the first one more to the right. So what we really will be doing is PT. So remember, guys, your first will come to the right, and the second one will come there. So it kind of, kind of look contrary to what you would have done. But remember, the matrix that's going to work first must go to the right. We have to remember that. All right. No, you don't need to break down the half. It's fine. Decimals are not necessarily needed. All right. All right, guys. So we're talking about PT there. So we're going to put PT together. P. Put the P first. 0, 1, 1, negative 2. That's our P. And our T is what we had before. I think it's 2, negative 1, 2, 0. I love to double check. 2, negative 1, 2, 0. Making sure. All right. So we're talking about 2, negative 1, 2, 0. So you want to put together this, and this would have given you your combined transformation. Remember now, it's row by column, right? Row by column. So I just going to highlight my rows, row 1, row 2, and then I'll highlight the columns in yellow. Column 1, oh, it's still green. All right, let me just put it. Column 1, column 2. All right, let's focus. So row 1, row 2, column 1, column 2. So we're going to go row 1, column 1. So we're talking about 0 times 2 plus 1 times 2. 0 times 2 plus 1 times 2, right there. Row 1, column 2, 0 times negative 1 plus 1 times 0. Then row 2, column 1, 1 times 2 plus negative 2 times 2. Then row 2, column 2, 1 times negative 1 plus negative 2 times 0. And we take our time, make sure that there's no error, because with this, a lot of times we know what to do, right? But the calculation will be tedious, little things, So we try not to error. So let us do one more step. This is 0 plus 2. Then I have a 0 plus 0. And where are we now? We have 2 plus negative 4. I have a negative 1 plus 0. Let's break it down some more. Finally, I'm getting 2, 0, negative 2, negative 1. So when you take your time, work your thing, try not to error. 2, 0, negative 2, negative 1. And there it is. This represents, what this does, it represents one complete transformation that deals with two things in one. So whatever the P and the T would have done, if you did them one by one, this new thing can do the shifting, a double shifting in one go. So that is why it's called a combined transformation. So we have a matrix for that. So it's regular matrix. The only thing about this is that we have to make sure that we understand how to set this up based on information, T followed by P. Which one do I write to the left or the right? Make note of that, all right? All right, let's look at the next question. Hence, find the image of the point 1, 4 under the combined transformation.
Sir,
Go ahead, go ahead.
in Algebra, it's going to be about.
Oh, I started at number 10. We start at number 10. So we're at number 10. I'm kind of doing the more difficult one first. So I'm at number 10.
Okay.
All right, good. All right. So B part of number 10 says hence. And we know that hence means that go back for your last response. Find the image of 1, 4 under that combined transformation. So we all know that you're going to put that combined transformation to the left. And then you're going to write the point. So this is the combined PT. And then you're going to put this point, which is 1, 4, here. Carry out this, right? So it's going to be the regular row by column. What are we doing? 2 times 1 plus 0 times 4. Then -2 times 1 plus -1 times 4. What are we looking at? 2 plus 0, -2, -4. Finally, what do we have? 2, -6. So this is the image. So the image, making sure we represent properly, the image would be 2, -6. Because we are putting it back in coordinate form. Have to be very careful there, right? Coordinate form. We don't want to leave it in a vector form. This is not a coordinate. So you have to make sure that you represent, right? Properly and clearly. Right, so as you could see, your matrices can come in a transformation. This is what they gave for the matrices, that here. Transformation question. That's fine. Apply yourself to it. All right, let's continue working. Now, here comes a vector question.
Sir, could I go a little bit more? Can I see the answer, sir?
All right, here it is.
Okay, sir.
Good?
Yes, sir.
All right. All right, so now what we're looking at there, as you could see, what we're looking at now is this. Hold on, guys. Let me fix this thing on the screen here. All right. So what we're looking at now, we're looking at a diagram. It says the diagram below, not drawn to scale, shows a quadrilateral ABCD in which AB is M. You're seeing that. Take a look. AB is M. We're seeing that. DC is 3M. You're seeing that. AD is N, and you're seeing that. Pay attention to the arrows, right? Remember we said vectors, the arrows is so important. Look at this one, it's going down. This one is going that way. Make sure you take note. Because when you're moving, you want to make sure that the moment you realize that you're going to go opposite to that arrow, you change the sign, right? So let's see what they want from us. First question. Complete the statement below, right? On the geometrical property of the following vectors. AB and DC are what? AB and DC, let me highlight them. AB, DC, look at the arrows on them and everything. What do they depict? They are what? AB and DC Now, look at AB. Let me write this for you so you could make a decision. AB is given by M. DC is given by 3M. Anybody want to make a quick conclusion when you see this? What could you say? They are what? When once, when twice. They are parallel. Remember, if you can multiply or divide one vector by any number and you get the next vector, that means that they are parallel, right? So you could see that 3 times AB give me DC, all right? And if I divide DC by 3, I get AB. So they are parallel vectors. So we're completing the sentence. Now look at this. AB is dash times, we're talking about the length. You see the modular symbol, the length symbol there? Look, that, take note, right? We're noticing this, that, which would have signified the size. So basically then, the size of AB is dash times the size of BC. Now, what do you think? What size? What's the number? What's that scalar number? Anybody? Look at it.
3, sir.
All right, you're thinking, but I want you to think carefully. 3 is a good number. However, how did they phrase the question? Look, which one is bigger? Is it DC or AB? CD, huh?
DC is bigger.
All right, yes. So then it is bigger. How many times bigger? 3 times bigger. But how they put the question, you can't put 3 for the answer because they said AB, the length of AB is dash times the length of BC. So if you put 3, you're telling me that the other one is 9.
There's
You have
gonna
to
be
put 1/3 of it.
third.
Be careful, be careful. So yes, you understand everything, but how they phrase the question, you now have to be careful how you respond. You can know the thing and just, you know, not reading properly. And then, because look here, AB is 1/3 times this. Of course, let us do it. So if I take 3M and I multiply by 1/3, see that? I will get M, which is AB. So 1/3 of that CD would have given me AB. So we want to be careful with that. So it's 1/3. Now the next question says, express BC in terms of M. So let us take a look, BC. We want to express BC in terms of M. So we want to travel here. Now we're thinking, if I want to go there, what's going to be the route? So when you get the vector, you're going to have to look on a way that you could move from B and end up at C. You will agree that you're going to have to travel this way. You're going to travel B to A to D, and then D to C. So I want us to embrace that. We're going to travel that direction. So then BC is equal to D to A plus A to D plus D to C. And you can always look at your beginning and the end, you know, and you should be able to see what they had asked. B starting, ended at C. So what we want to do now is simply put our numbers, our values, whatever. Now let's look at BA. We're going the opposite direction of that. So we're gonna go negative M because the direction changed, we're going this way, right? Now let's take a look at the next one. We're coming the right direction, so it's gonna be plus N. And the 3, so DC, I'm going the right direction as well, so it's 3M. Let's add, simplify. So I'll have an N and a positive 2m. So you want to look at what you're doing. So that is BC, n and a positive 2m. That's our BC right there.
Sir, go back a little to where you was having. Okay, sir.
Okay. All right. All right. No, not bad. Not bad. Not a bad question, as you could see. Not a bad question. All right. So 1 mark, so you see, they're not, because they know that you could just easily snap your fingers and you're moving like that, right? Now, L is the midpoint of CD. Find BL in terms of M and N. L is the midpoint of CD. Let us go and put that. CD. L is the midpoint of CD. All right, so they have that. And then what it is that they want us to find? BL. All right, so we're supposed to find from B to L. Let me clear the diagram up a little bit now. All right, here we go. So we want to find BL. That direction. Now, because L is the midpoint, then from D to L is going to be 3 over 2m. And then from L to C will be 3 over 2m. Because what you did was you want to split that 3 into 2 equal pieces, right? So you're moving like that based on information. So now that I have all of that, then I can easily find BL. Let's put it together. BL. Just want to put it here where the diagram is. I'm going to move from B. Well, there are a lot of things you could do here. All right. You want to go the triangle, you could go this way. Look at this. Look at this. Let me just mark this fast. You know that you could move this. This is the easier road, right? And then you come like this. See that? Easy road. Easy, easy. So I'm just going to take that road, right? So BL, I'm going to move from B to C, and we just did that. We know what BC is. Also, I'm going to move from C to L. I'm going to come that direction. B to C, C to L. We just did BC, and BC was N plus 2M. That's BC. CL, watch direction. So we're going against the arrow. So it's going to be a minus 3 over 2m. That's all. Right? So now we can now put things together by simplifying everything. There is no n, so the n will remain. But I want you to think about this. If I have 2m and I'm subtracting 1.5m, what am I left with? 2m minus 1.5m. I am definitely left with positive half m. Regular. So we want you to look at those questions regular, especially the vectors. When you touch the algebra, you're simplifying algebraic terms. Just take your time, right? So 2m minus 1.5m, because 3 over 2 is 1.5. Then you're going to be left with half m. You're done. All right. So that is BL. We're done right there. So there it is. That's the last question there for that. So it wasn't a bad question. Let's go to question 9. All right. So we're going backwards this time. I want to catch, bigger questions early before you get tired. Question 9 is titled Geometry and Trigonometry, as you could see, right? Geometric tricks. Now, let's go. Here are the questions. It says here, the diagram below, not drawn to scale, shows the relative positions of 3 reservoirs, B, F, and G, all on level ground. The distance BF is 32 km, FG is 55, and the angle BFG is 103. And we're seeing those on the diagram. And F is the bearing. F is on a bearing of 42 degrees from B. It's on the diagram. So the diagram is well, labeled and everything. Let's see the first question. The first question says here, determine the bearing of B from F. Determine the bearing of B, but from F. Normally, when we get these questions, what I want us to do, let us go at F. So it's from F. You could go at F and you want to drop your north line here. All right? You want to drop your north line. So now you want the bearing of B from F. In other words, you want all of this. What you want is all of this. All of that angle. There are a number of ways to do it, but take a good look. A very easy way to do this now is to look. Let me extend this line for clarity. You will agree that this here would have been 180 degrees right here. That's from north to south. So if this is north to south, 180. So all I need to do is to patch that with the little piece in green to get the bearing. And this is just one way, because I have other ways we could do it right now. And I feel like I might want to do it. So then, you will agree also that Z angles are equal. Alternate angles are equal, which means that this is 42. So then, the bearing of B from F will be a combination of 180 plus 42. Check that out. 180 plus 42. And this will give us about 222 degrees. That's the bearing. Now, what if you never saw that? Then what we could do is this. So let me just show you something at the side here. Method 2. Another method we could do to find that bearing. You would have had here B, F. You do know that the north lines are parallel to each other. This is 42. So we want to take note of this that we're going to be looking at. It's very important. When you have two north lines, they are parallel to each other. This line here becomes a transversal. Co-interior angles add to make 180. They add to make 180. Now, see where we're going. If I take 42 from 180, I'm going to get 138 degrees, which is this angle here. Now, look at the bearing. This is B. The bearing you wanted was all of this. Now, the red arrow system with the blue up there would have formed a full circle. I want us to think. It does form a full circle, where the bearing that I really want is going to be this yellow here that I want. This is the bearing. I want all of that angle right there. All of that angle. Isn't it true that if I take my 360 and I take out that 138, I will get the same answer? 2, 2, 2. It's up to you how you want to approach it, right? But the key thing is you want to mark the bearing, take a look at it. Most times there are a number of ways to get there. Get there the way that you understand best. So that's much I'll say. Won't force you to do any method. So there it is, 2 methods quickly. The next question says, calculate the distance BG, giving your answer to 1 decimal place, right? Now, so we want to take note of the 1 decimal place, but we're looking at BG. Take a look at BG. I'm going to clear the diagram up so that we can have a good visual. So now they want us to find BG. I'm going to highlight it in yellow. We're supposed to be finding that. Now, as you could see, we know everything in this corner here. My little corner here in blue, we know everything here. Why? We have the length of the sides, right? So we have an angle between 2 sides, and the intention is to find the side across from the angle. The moment that you see that, then the cosine rule should now just jump out at you. The cosine rule, right? So the cosine rule will jump out at you. I'm going to do it right here. So the cosine rule says that BG square is going to equal to 32 square plus 55 square minus 2 times 32 times 55 times the cosine of the angle that is there. All right. So then we're looking at that. So now let's do our calculation, making sure that we're not making any error. 32 square, I think that gives us 1,024. 55 square, it's going to give us about 3,025. And then now I'm going to put all of this on the calculator at once, all of that from -2. All right. So it's -2 times 32 times 55 times the cosine of 103. And I'm getting a positive 1. So I'm getting a positive 791.8. So we're going. Let's put all of that together. So now I could write BG square is 1,024 plus 3,025 plus 791.8. Make sure that everything is spot on. And I'm getting here 4,840.8. Finally, right? Finally, let's take the square root of this. Let's take the square root of that. And I'm getting here for BG. I'm getting 69.575. But remember, they did say to 1 dp. So BG is approximately 69.6 kilometers. As you could see here, we are doing some tricks, yeah? And you're applying yourself. The main thing is no error, right? Try not to make any error as you flow. All right, so I'm gonna put this here. This is 69.6. There it is. All right, not bad, not bad, not bad at all. Let's continue moving. Now, the next question says here, calculate to the nearest degree the bearing of G from B. To the nearest degree, the bearing of G from B. Be careful, G, but from B. Okay, so they want me to find, so I'm gonna go at B, and then when I go at B, we're gonna actually go to the north of the point, clockwise motion, until I reach the line that leads to G. So I need all of that angle in green. But what we're noticing though, is that we would have had 42 degrees out of it. So if I have 42 degrees out of that already, it simply means then that this is the only part that I need. I only need to find this angle inside the triangle. So if I should find that angle inside the triangle right here, and add that to 42, then I'll get that bearing of G, but from B, right? So let's take our time to put that together. What concept are we going to be using? Well, we're going to be using the sine rule now. It's a little bit safer because I'm looking at angles and opposite sides. Whenever I see that, I just use the sine. So I have 103 degrees and I have 69.6 opposite to it. The angle that I want to find, I have the side opposite to it. So we're going to employ A over sine A, B over sine B, and use that to guide us through it, right? A over sine A, B over sine of B. All right, let's go. I'm going to work it down there. So we're talking about using A over the sine of A, which is equal to B over the sine of B. Right? All right, so if you want to have a quick little visual, hold on. Let me just help us right there. To have a quick little visual. All right, just a quick little visual to go back and forth so that you could see the diagram as you go. All right, so if I go to the question now, all right, so we could see what we're doing, all right. All right, there it is. All right, so A over sine A. So what are we looking at? 69.6 over the sine of 103. That is going to equal to 55 over the sine of the angle that we want inside the triangle. This angle, we need that. So basically what we want to do now is to employ a quick cross multiplication. So it's up to you, I mean, so I'm going to cross multiply. So I'm going to take this down here. It's going to multiply by that one over there. I'm going to take the sine of the angle, multiply by the 69. So I'm going across. So I call it cross multiplication. So what do we have? We have 69.6 times the sine of the angle. And that is going to equal to 55 times the sine of 103 degrees. Remember, the intention is to isolate this. So I'm going to divide both sides by 69.6. And then from there, we can use a calculator to take us out. Let's go. So what are we talking about? 55 times the sine of 103. We want to divide that by 69.6. All could go on your calculator at once. And so, all right, let me put it right here. So the sine of the angle is this value. The sine of the angle gives us this. All right, I'm going to have to go up to 7 because I have 99. So I'm going to have to go 0.7700, all right? Because I have 0.99. All right. So then, what we're going to do now, though, to find this value of the angle is to use our inverse. So inverse sine 0.77, you could put the zeros there if you want, doesn't matter. Inverse sine of 0.77, and it's going to give me about 50.4. So the angle that we're trying to find is 50.35, which is 50.4 degrees. Now, how are we going to be using that, right? So we use that, we find the angle that we're looking for. Where we're going to put it? We're going to put it right here. We're going to put it right here, 50.4. So we're going to be adding the 42 with the 50.4 to get everything coming to that line. Let's go back. So then the bearing is going to be our 42 degrees plus the 50.4. And we're looking at about 92.4 degrees. But the question said to the nearest degree. Well, we're going to have to round this off properly now to 92 degrees, right? Have to put it to 92 degrees. Or if you want to put 0.92, that's fine. Hope everybody see what's going on there. So originally we got this, but the question said the nearest degree. So because the 0.4 does not reach 5 yet, we have to round down to a 92. So I'm just using the 3-digit system here and say 0.92 because bearings are normally given like that. So that's that. Bearing question is finished. The bearing question is actually finished right there. So now we're at circle theory.
So I'm gonna finish it.
Yeah, man, I'm gonna go back. I'm gonna go back. I'm looking for something for you. Looking for something so that I'm ready when it comes. There it is. All right. So make note. So if you notice these questions, I mean, interpretation is key. Pulling back on your previous knowledge, having the confidence to put it down, take your time, you know, try work not to make any errors and go forward. You have to make sure as well that you're reading what they want so that you could respond appropriately. All right, Rihanna, ready to go? All right, any questions surrounding that? Are we good?
Yes, sir.
All right. All right, let me move this. All right. All right, let's take a look at what's going on here. All right, so what we have now is it says that the diagram below, not drawn to scale, shows a circle with center O. The points A, B, C, and M are on the circumference. You're seeing that. The straight line CN is a tangent to the circle at the point C and is perpendicular to BN. You're seeing everything that they're saying right there, right? So what we want to do is to take a look at what the questions that they have for us. So we're going to be looking at the questions here. We're going to view the diagram there, right? So there it is. We put this back over there. All right. So we have the questions there. We're going to view the diagram right there. First question. Determine, give a reason. I want you to pay attention. I always highlight this. They never said give all the reasons. You're going to give an important reason to you right there. Singular. Right? So determine, giving a reason for your answer. Angle ABC, following the flow of the 3 letters, the angle is always in the middle. So we're going to mark the angle first, ABC, ABC. That's the angle that they want. ABC. So you want to make sure that you mark the angle. So we want to find ABC. Take a good look. This is a diameter. Yeah. Yeah. Right. So because of that, you're going to notice that. Take a look at this nicely formed triangle that was cut out in the semicircle for you. Right. So you want to use that to drag your memory. Right. Because I don't have enough information yet. But when I look closely, I realize that, hey, that's a right angle here because angle in a semicircle is 90. So this angle here is 90 degrees. So because I am aware of that now, I can now find this because it's going to be the third angle out of those 3. So it's going to be the third. So what is going to be equal to is that it's going to be 180 degrees, which is the total sum for all the angles being added in the triangle. And I want to subtract the 90 plus the 58. And what are we talking about here? I could go back to this. So let me just put it here. 100 minus that 90 plus that 58. So we're talking about 180 minus 148. And this will give you 32 degrees. All right, very good. So it is 32 degrees. So this angle here is 32 degrees. Now, what's the reason for it? The reason we got that was that we realized that angle in a semicircle is 90 degrees. We saw that because if we never found out that that was 90, having the 58 wouldn't help us. But the 90 complemented that so that we could now put everything together and we came out of it. All right. All right, good. Good, good, good. All right. CMB. Gonna take a look at that. CMB. We gotta mark that angle. CMB. CMB. Right here. Right there. Now, when you look at these diagrams, you make a quick look, you want to see what's going on. You have to be thinking all the rules that you know. But you want to take a look at this idea that I'm seeing a four-sided figure. I will highlight it for you. I'm seeing it. And you could see that all the vertices, they're resting. All the vertices, they're resting on the circumference. And because of that fact, what are we looking at there? We're actually looking at a cyclic quadrilateral. So what's the rule for the cyclic quad? Opposite angles add to give 180 degrees. What do we mean? This angle is opposite to that. And this angle here is opposite to those. But the ones that we are working with would have been this one and that one. So that's what we need. So all we're going to have to do now is to take that 58 from 180 degrees. Let me pull off the decorations. So then for this one, it's going to simply equal to 180 degrees minus that 58, right? And what do we get? About 122. 122 degrees. Let me put it on. I like to put them on. This is 122 degrees. And what's going to be my reason? Opposite angles in a cyclic quad add to 180. Or you could say opposite angle in a cyclic quadrilateral are supplementary, right? That's another thing that you could have said. That's fine as well. But you could write add to give 180 degrees. Now, what you notice, 2 marks for your circle. One is to give this value, and the other one is for the reason. So you want to make sure that you know the reasons as you go, because the reasons are there. So you can always study them, look over them so that you don't drop any marks, right? Just study them so you don't drop any marks. Let's continue going. Next one, NCM. Go back to your diagram, look, mark it. NCM. We want to find this. You want to find that angle there. What can we put together now to find it? So you have to be thinking, you know, you have to be looking, you know, to make sure that you can figure out what's going on. It's up to you to look. But I did say NCM. Watch this approach. I could come inside here following this straight line there. That's a straight line. So angles on a straight line would give me 180, which means if I have 180 and I take the one, and I take that 122 from that, I think it's gonna give me about 58, right? Yeah. So it's gonna give me 58 here. So that is 58 in that little triangle there. Let me highlight the little triangle. Let me use the smallest pen. Here's the little triangle. So the angle I want is right over there, but I have 90 degrees in that little triangle. I have 58. So right now, I can now figure out what this angle is right there, right? So it's gonna be, hold on. We're gonna have to say, all right, first move, I took out the 58. No, I took out the 122. And I'm left with 58 for that. Now I'm gonna say 180 minus the sum of that 90 plus that 58. And then you're gonna get 180 minus 148. You're gonna get 32 again, right? So that angle right there is, let me go back, I'll give you the chance to write. This angle right here is 32. Let me use clear. Let me put it red, 32. That little angle that they asked for is 32. I mean, there are two things that we use. It's up to you to write the right one. Not the right one, the one that you think worked for you. So you could have said, the first thing that really helped me was a straight angle. A straight angle is 180. That gave me the 58. Another thing that could have helped you was that the total internal angles of a triangle is 180 degrees. That also helped you. So you could have written any one of them and it would have worked for you because you use one early and use the other one in the end. That is circle theorem. You only need to write one, right? So you work out your thing, look at what you have, make sure that everything makes sense, and then you flow. There it is. We're decorating our diagram. There we have that. Finish. Let us look if there's another. Nope, we're done. So as you could see, that's a number 9 we finished. You do notice that these are 12 marks. This is 2018 anyways. All right, let's go. Can we now go to number 8? We want to look to see what number 8 is about. All right, number 8. All right, here comes number 8. Number 8 is titled So it's really titled Algebra, Relation, Function, Graph, right? So there it is. Let me put this here. All right, let's look. So this time it says the diagram on page 25 shows 6 points. So we got 6 points, as you could see. Here's the function y is equal to 3x plus 1 over x. It's not a quadratic. All right, so it's not always going to be a quadratic. It's not always going to be a straight line. It's what it is. So they say it's y is equal to 3x plus 1 over x. Fine. Doesn't matter. We're going to plug these in and we're going to work. The coordinates of these 6 points are given in the table below. You're seeing the ones that we got. We got these, we got that, we got that, we got that, we got that, we got that. So we actually got 6 already. What we need though is to fill out these 2 little spots. We want to know what that is, what that is. We do have the X values though that we're gonna plug in together. We do have them. So then when they want us to complete the table here, all right, to fill out those missing Y values, you're gonna do the regular. Y is equal to what? 3x plus 1 over x. So then we're gonna now put in when x is a half on your calculator. So 3, hold on, times a half plus 1 over a half. Put it on. Put that on. What do you get?
3.5.
1.5 plus 2 will give me 3.5. The next move is that we're going to put in 2. So this one we plug in when x is the 0.5 there. And now we want to plug in when x is 2 here. So then this becomes 6 plus a half, 6.5. Huh? So I'm getting a 6.5 right here. So a lot of times people take a look at the ideas and they feel funny, they feel weird. Do not do that to yourself. Just take your time, right? Take your time and do what you have to do. So there it is. You would have collected 2 marks to complete that easily. 2 marks. So now what we want to do is to see what else they want us to do. Number 2, it says on the diagram on page 25, the order pairs shown in the table have been plotted except for the missing ones. So they are saying they plot everything already except the missing ones. Using your answer in AI, which is what we just got to complete the table, plot the missing points and connect all points with a smooth curve. See, they're forcing you. They're forcing you not to use a straight line, right? Please remember, be careful. So with a smooth curve. So we're going to be plotting those points. What we're going to plot is 0.5 with 3.5 and 2 with 6.5. Allow me to go back to this. I believe I would have had it somewhere. Here it is. All right, good. I have it. All right, I have it right there. Oh, I think I left off my, I think I left off the, all right. Give me a minute, let me get back this diagram because I left off the x-axis. All right, give me a second. Oh, that's what I left off right there. Allow me to fix this quickly. I'm off the screen. Let me minimize this to something that I could capture. All right, I think that's good enough. All right. All right, I might just put this. All right, let me go back up with that. All right, a little bit too big there. All right, good. All right, let me go back to this. I'm gonna take this off. Put this there. All right. Not gonna crop it, no. All right. All right. This could work. I think it's all right. Yeah, it could work right now. All right. So what we're gonna do now is to do the plotting. All right. Let me go back to this. Let me get the table now. There's the table of values. Come back to this. All right. So we want to plot 0.5. Take a look at it. 0.5 with 3.5. 0.5 with 3.5. We wanna take note though. We wanna take note. Take note of where your 0.5 would have been because you're looking at where 1 is. Look at 1, look at 0. 0.5 has to be in the middle coming up right here. All right. 0.5 is right there. So you have to follow your 0.5 and you're gonna go up to 3.5 right here. Right there. All right, this is 3.5 here. And we have a 0.5 here. All right, plot that point, of course. Then plot the next point, 2 with 6.5. Follow your 2 line. Here is 2 going up, right? And we're going up to 6.5. It's right here. Now, remember, we're not always going to have quadratics, right? It's not always about quadratics. So it's going to be coming from up here. Turn it. There it is. All right, I might miss right there, but basically, right? So you just flow into it right there and make sure that you connect properly, right? So basically your curve looks like that. So it's not a quadratic curve. You saw that there was no x squared thing going on. So you plot it still, collect your marks, and you go right there. All right, so as you could see, maybe they thought it would have been a little bit discouraging. So they did all the work and they said, plot these two, connect this for me. And we did that and we're good, right? So it's not a lot of work. Let us see what else they want us to do. So we collected 2 marks here for that. Yeah. Now, the third thing is, they says, by join appropriate lines, very important, see there? On the diagram, find approximate solutions to 3x plus 1 over x equals 6. Remember, I know, y was equal to 3x plus 1 over 6. Y is equal to that. You do notice that this is the same thing like this, except this 6 took the place for the y. In other words, they are saying to you, go on your y-axis because the 6 took the place of the y. So go on your y-axis and see where 6 is. Run a line through it and see what values we get. Solutions will be the x values coming from that, right? So watch this now. Let's go to this. We're going to take a line out, yeah? And we're going to go where 6 is. There it is. And you're going to draw that proper. There it is. And they did say use appropriate lines. I'm going to change the color for you to see it a little bit clearer. I don't know if that is clear enough. Not. Red. Maybe. I'll let the red stay. So you're seeing now that, let me push this across now to get what we want to do now. Hold on. I'm going to blow this up now. Right? Oh, I did. All right, the 6 is gone. Let me go back. All right, there it is. All right. So what we want to do is to focus on where it touches the curve. Wherever I touch the curve, you're going to take a line and read off. You're going to read off that number. You're going to read off that number. So basically, you take it, you come down, you just read off those numbers down there, right? So you want to read off those numbers. So here are the solutions. Whatever that is, whatever this is, we're going to be reading them off. So now, what you want to do is to have a good idea of what you're looking at. So let's go down there and blow it up so that we can look. Take a look. All right. Remember, it's what you get. So that I think this is big enough. So let's do some observation quickly to get this answer out. Let me take off these unnecessary lines. Let's take some look at what we have. So it came down at these two places, right? So you want to figure, so this one looks like it comes on there. That's fine. This comes on a line. That's fine. So you kind of want to figure out what these lines worth, right? So it's up to you, you know, it's up to you to figure out. So maybe 1.2, think about this 0.2, 0.4, 0.6, 0.8, then 2. So you could see that already. All right, so you could see that 1.2, I'm just saying 1.4, 1.6, 1.8, and then 2. So you kind of have an idea of what's going on. This is like a 0.2. So now what we're going to do now is to try to pick up the ideas. We want to pick up some ideas. Let's pick them up. So you're going to go between this some more. Think about this. 1, 2, 3, 4, 5. Between 0.6 to 0.8. 0.6 to 0.8. You can do that from now, or you could have split up between 1 to 2 in all the little pieces that you see. You can do that. Or since you know that we have 1.2, 1.4, you could work between that. So if you have a 1.8, if you take 1.6 from it, the gap is 0.2. But that 0.2, this is a 0.2 gap in it. It was divided up into how many pieces? 5. That 0.2 was divided up into 5. That 0.2 was divided up into 5. So I'll know what one of these lines is now. 0.2 divided up by 5. It's 0.04. All right. So depending on how you want to do it, it's 0.04. So then for the solution here, it's 1.8 minus 0.04 because it's 1 less. So I could take it from it. So I take 1.8 minus 0.04 and I'm getting 1.76. Remember, this is conditional to my drawing. So you might not came down at the same place, but you have to interpret your answer. So my answer, one of my answer is x is equal to 1.76. That's where my line came down. Yours may not come down there. So I'm working mine. Now over this side, where my line came down here, right? Remember now, one of these lines is 0.04, right? So this is 0.04. See them there? See them there? 0.04, 0.04. All right. So then I'll have these first 3. It's up to you. These first 3 is like a 0.12. 0.12 come here. This is 0.12 come here. And I'm in the middle of this and this. All right. I'm in the middle of these 2. Check it out. Think about this. I have 0.12. This line would have been 0.16. I want to go in the middle of it, basically. All right, it's roughly, it's in the middle. So you could add them and divide by 2. And you get the middle. Just like when you find midterm. So it's going to be 0.14. So I'm just showing you how to get it, you know. If you're between 0.12 and 0.16, you're between that. Add them, divide by 2. Or you could check it in your mind. 0.14 makes sense. So my other solution is where x is equal to 0.14. That's what I have based on where my line comes down. So I'm not going to tell you that somebody else would be the same depending on where their line came down. Look, that's where mine touched here, mine touch here. So my curve might lean a little bit, but that's where it touches it. So they want you to interpret your solution, right? So at this point, they're testing to see how well you can read off yours, right? So mine, 0.14, and the other one was 1.76. That's what I got. So as you could see, sometimes they will pressure you. Look at the scale. When last have you seen a scale look like this? Understand? So it doesn't matter. One has to take the time to figure out what's going on. Not saying it's going to be easy, but you have to focus. All right? So it's the same ideas, but we have a smaller scale working with there. So our solutions are x is equal to 0.14, x is equal to 0. What was it? Or was it 1.76? I think it was 1.76. Let me write it. 1.76. So those are the two solutions I got based on my diagram. Mine. Here they are. Take them down, and then interpret. All right. Let's continue working. That's the graph that we did not use. All right, so we're looking at speed, velocity, time graph here. Speed against time, here it is. Speed against time. All right, let's see what we get. All right, let's continue. Let's see what we have. Now, the first question says, calculate the acceleration in meters per second square of the car in stage B. I want to take the time out to tell us something. When you're doing speed against time or velocity against time, the acceleration is the gradient. Acceleration is the gradient. Always. Acceleration is the gradient. So then, in stage B, you're simply moving from here to there. What is the gradient? Acceleration is the gradient. So you want to take a note of this, which is this number, 15. You want to take of this, which is this number, 40. This and this. So these are my points, right? So I wanna make note that acceleration is change in velocity or change. Where could I write this? Let me write it here. Acceleration is change in velocity or speed over the change in the time. That is why we said it's the gradient, because the change in the speed is going to give you the rise. And the change in the time is going to give you the run. So the rise over run idea, right? So it's 40 minus 15. 40 minus 15 over 60 minus 40. Let's take a look at it. Talking about B, see it here? 40 minus 15 give us this over 60 minus 40 give us this. So in other words then, if you should go like this, you would have seen a nice right angle triangle. See there? This and this. Let's take it off. All right. Take off this too. Take off some of these. All right. So we're dealing with those. 40 minus 15 gives us what? 25 over 20. And 25 over 20 is about 1.25 meters per second square. There you go. Just like that. Yeah, you could. But because you could use decimal since the speed and everything there. All right. It's a 1 mark question. So you see it's not a big deal. Next question. Calculate the average speed of the car during stage B. Average speed during stage B. Average speed is always total distance over total time. Average speed, let me write this first. What is average speed? Total distance over total time. Here's the thing. You know the total time already, right? Now we're talking about in stage B. Stage B, the time is from 40 to 60. So that's 20. Is the distance you need to find. But to find the distance, it's going to be area under the curve, area of the shape. Let's look at the shape for B. Take a look. Here's the shape for B. That's the shape for B. The shape for B is a trapezium. So if we want to find the average speed, we need distance. The area of the shape seen under the curve is equivalent to the distance traveled. So now we're going to have to label up this. I'm seeing where this is 15, that side, and the other big side is 40. And the height is going to be 20 down here. Talking about the trapezium. So you're talking about a thing that looks like this. 20, 15, 40. So the area of the trapezium is half the sum of the parallel sides times the height. So then, let's work out the area of trapezium right here. So it's going to be half the sum of the parallel sides times the height. Half the parallel sum of the parallel sides, 15, 40. So it's going to be half 40 plus 15 times 20. Let's take our time and work that out. Try not to make any error. I'm getting about 550. When I maths out this, I'm getting 550 meters. So the units that we're using is meters, see there, per second, so it's meters. So I have the distance. This is the distance traveled in B. I now need that distance here to work out average speed, because average speed has distance in it. So this is 550 that we're waiting on. So then finally, 550 divided by the 20 is going to give me the average speed of 27.5 meters per second. Don't leave off the unit. It's meters per second. Remember this idea though, a lot of times when they do it, you have to be careful, right? Look at what you have. The concept is here, average speed, total distance over total time. The time is always on the axis, but you may not always find that total distance. You may not always get it, so you're going to have to make sure you put things together so that you can properly deal with it. All right, let's continue. See what the question is. Now, here is the question right there, 60. So additionally, it says at t equals 60. So when the time reaches 60 seconds, the car starts to slow down with a uniform deceleration at this. All right. So uniform deceleration comes from the term acceleration. Acceleration really means to speed up, but because you're slowing down, it's like we call it a negative acceleration. deceleration, retardation. So we are cutting up our speed, but how are we cutting it? We're cutting it by 2.5 meters per second square, right? So we're cutting it down. 2.5 is coming off. 2.5 is coming off, coming off, coming off. So if think about that, that's what is going on. So here's the question. Determine how long until it take the car to come to rest. It's 1 mark, you know. Now, think about this. What speed do we have now? You agree that we're at 40 right now? Because the question is saying at 60 seconds, it starts to slow down. So I want to know what is my speed at 60. Let me clear up the diagram so that we could take a good look. What is my speed at 60? At 60 seconds, my speed is 40. Oh, so if my speed is 40, and then I'm going to be dropping 2.5 meters per second every second, how long before it comes to 0? You could simply think about it and you get the answer. You know? Because we're talking about, watch this, the time for it to come to rest. The time for it to come to rest, right? How long until it takes the car to come to rest? 40. If you divide this by 2.5, you know what that's going to give you? Think about that. It's going to say 16 seconds. Think about the reality though. If my car is moving at 40 meters per second, and I'm slowing down at 2.5 meters every second, after 16 seconds, I am now at 0. Makes sense? Because dividing is repeating, or repeated subtraction is actually division. So I minus 2.5 minus 0.25 minus 2.5 minus 2.5. It's like dividing by 2.5, 16 seconds. And that is why it's a 1 mark question. By the snap of the fingers, we're done. 16 seconds, and that car would come to rest, which means to stop. It's done. Hold on. There are no more questions there. Hold on, let me look. Okay. How long it will take the car to come to rest? 16 seconds. Okay. I thought there was another question. Huh?
Yes, still number 9.
I know, man. What I'm looking for, if there was another question, I was looking to see if we had more question. Well, we finished. Yeah, it's finished. All right, it's finished. So you can see that the speed velocity thing can work with. All right. So that's number 8, Rihanna. We just finished the number 8, so we're going to number 7 now. And number 7 is the nice one. Make sure that when you're doing the exam, you do this. Understand? All right. So we're gonna have a talk, anyways. All right. So here's the deal. Number 7, that's where we're at. And number 7 says a sequence of figures is made from squares of unit length. The first 3 figures in the sequence are shown. Figure 1, figure 2, figure 3. Draw figure 4 of the sequence. Okay. Now, normally what you do, you observe these first. And then after you observe, then you sort your one. Right? So we want to observe everything there first. Look, what it is that you notice being added, because this is like figure 1 already. And we're adding this at the side. You see what we're adding is this. So let me mark what we're adding. We're just adding this at the side. And look again. This is figure 3. What are we doing? We're adding this at the side. Oh, yes, I'm going to draw back figure 3 and add something like that for figure 4. So then I have to draw this. You take your ruler out the way, not free and like me right now. Take your ruler out. You draw your thing, right? All right. Two, 4, 6, 7, 2, 4. All right, so that is figure 3 already, right? But you could see that what we're gonna do now is just to add, right? This at the side, right? Hold on. No, man, I figure 1 this. All of this is figure 3. Count off the things. Take a look. 1, 2, 3, 4, 5, 6, 7. See there? 1, 2, 3, 4, 5, 6, 7. That's figure 3. So what you're going to do now is to look. Look how they add these though. Look. You would have had the previous one and you extend this box here. And then you put a box on top of it. So it's like you extend this box here. And you put a box on top of it. I'm just saying that's what you do each time. Extend this box and you put a box on top of it and you get this one. So that's what it's going.
Sir.
Yes.
Like a stairs, sir. Like one stairs. Yeah.
It is like a stairs. It is a stairs. But you need to see the pattern and you put it on. So what we really added on was this. What is where you add it? We extend this line. You understand? So you make a double line again, make sure it's 2, you put 1 on top. So that's the basic idea. So you want to make sure that you have that. So you do that and you collect 2 marks for that. It's always 2 marks every single time. So that's like a free 2 marks right there. Now you're going to go to the table now, where the question is saying, study the pattern of the numbers in each row of the table below. Each row relates to one of the figure in the sequence. All right. Some rows have not been included in the table. So they are saying to you, they skip out some stuff. Complete the rows, I, and I. So 1, 2, 3 there. First thing, so you want to complete this. I would say to you, based on what we have been doing of lately, sometimes you could multiply in your brain quickly and see. But other times you might struggle to find the pattern. I would say to you, there is a way that you don't have to worry. Look.
Adding 2 each.
You're adding 2 for this one, and this one you're adding what? 4. So that means you can easily create the end row, and then you use that to solve the rest of the problem. So we're going to take our time and do the end first. Remember now, the common difference is 2 for the first one we're doing. We're completing this one now. So the difference is 2. The first term is 3. The first term, we call it A. It's 3. So here is the formula. It's A plus N minus 1 D. A, 3. N minus 1 D is 2. Distribute, man. 2. 2 times N, 2N. 2 times -1, -2. Simplify. 2N plus 1. This is 2N plus 1. In other words, if you multiply anything over here by 2 and add 1 to it, you'll get the corresponding thing in the column over there. So we have that. Let's fill out the other one with the 4. Could do it up here. A is 8. D is 4. The formula to get the n row is A plus N minus 1 with a D. A, 8 plus N minus 1 with a D, which is 4. So 8 plus 4N minus 4. Simplify, 4N plus 4. I'm just saying that sometimes it's hard for you to just see quickly. I'm giving you something that just nail it. No thinking. Get your marks in the exam. 4N plus 4. Now you can use it to fill out anything you want. So I'm going to use it now to fill out this blank spot here, right now. So then it is the 43 is in the 2n plus 1 column, which means 2n plus 1 is 43. I need to find the n. So you minus 1 from both sides. 2n is equal to 42. Divide by 2. N is equal to 21. 21. Then I could use 21 with 4 times n. 4 times 21. Then I add 4. This looks like about 88. We'll fill out that. Now, these ones are very simple. You don't need to use n to do them because they are in properly sequence. Because 1, 2, 3, 4 is already lined up. So I could just keep adding my 2 to get my 9, add my 4 to get my 20 for those because they didn't skip. All right. So when you realize that they don't skip, then you can simply follow what's going on. But it's when they skip like this. This is telling you that they skip. So you don't know where they are after that. But before they skip, you could see it. Figure 1, figure 2, figure 3, figure 4, you could see that. You could see what's going on. That is 6 marks, you know. 6 are the easiest 6 marks this I'm seeing. Think how hard you work for the other 6 marks. And look how easily you're working for these. All right. Continue. Last question. Number 7 is finished. Determining the relationship between the number of squares, S, and the number of squares, S, and the perimeter, P, of the figure. Look at it. So they are saying, can you determine the relationship between those? Take a quick look and see if you see what's going on. Quick relationship.
Multiply by 2.
Multiply by?
2.
I don't think it's 2 because what do you mean by? You double it?
Yes, sir.
So you're saying if I
Sir.
multiply, look at it and you see for yourself. Take a quick look.
Sir, 2s plus 2 equals p.
Exactly. So if you have to take a look in the man. Take a look, man. So Jody, 2 times s plus 2 more give you the thing. Observe. 2
Yes, sir.
times. You see it? Yes, man.
Yes, sir.
So 2 times 3, we could work it out. 2 times 3, 6 plus 2, 8. Right? And if you have the 5 times the 2, you get 10 plus 2, you get 12. So you're like saying, oh, if I double this and add 2, I get these. Double it and add 2, I get them. And that is the relationship between S and P. So then you could come here and say, hey, the relationship is 2 times S plus 2. And we're done. 2 times S plus 2, and we're done. So look there, and you see it coming out quickly. You collect your marks, you get 10 easy marks. All right. Let's go to number 6. So that's number 7, you know. All right, so here's number 6 question. All right, so number 6 says, in the diagram, well, in this question, take pi should be 22/7. So we're going to take pi as 22/7 in this question. It says the diagram below, not drawn to scale, shows the cross-section of a circular metal disc of radius 21. A square hole with sides 6 mm is located in the center. You're looking at it. Looking at that. So they are saying to us, calculate the circumference of the disc. Well, you know what circumference is equal to? Circumference, C, is equal to 2 times pi times r. So it's going to be 2 times 22 over 7 times r, which is 21. So I could do a quick thing, 71, 3. So we put that together. 2 times 22 times 3. I'm getting about 132. So the perimeter is 132 millimeters. So we're doing regular circle thing now. Regular, huh? Regular, man, regular. Regular circle, circumference, 2 pi r, 2 pi r. Here you go. So that's the circumference, which is the distance along the boundary. Let's go to the next question. The area in millimeters squared of the cross section. So now we're going to have to think. Cross section they're talking about. Area of the cross section. Now the cross section is actually the entire thing except the hole. Because there's a hole in the middle, you notice? There's a square hole. So what I'm going to have to do here, I want to find the area of the circle. And then I'm going to subtract this hole because this is an empty space. So I'm going to find the area of the circle and then pluck out the area of the little square down there. That's the concept. Now, area of the cross section is going to equal to area of the circle minus area of square. All right, that square hole right there. So then, area of the circle, pi r square. Let's work out that. 22 over 7 times 21 times 21. Let's work out that. That's the area of the circle. And I'm getting here 1386. And this is mm square. Area of the square. One side is 6. So it's going to be 6 times 6. Let's take a look at it. If one side is 6, that means this is 6. So the area of the square is going to be 6, 36. Very straightforward, very simple. So this is going to give us 36 mm square. So now what we need to do is to subtract them, the cross-section area. We're going to minus that 36. So minus that 36, and I'm looking at 1,350. So that is the area of the cross-section. The disc that you're looking at, the entire flat surface, is that. All right? So focus area, we find the area of the circle, which is this. Found the area of the square hole, which is this. Then you subtract them, and we're looking at the area of the cross section. Right? So you find them, you put it together. All right, let's go. What the next question wants. It says, given that the thickness of the disc is 2 millimeters. So in other words, I have a disc with a little square hole in it. And then it is this thick. There's a thickness to it. And this thickness is 2. So I already have the area of the cross section. And then now the thickness of it is this. So they're going to ask about some value, right? So what they're saying is, given that it is this thick, calculate the maximum number of discs that can be constructed from this. Now, what I'm going to do is, I'm going to want to know all the space that this will take up, material that it will be using. All right, so I'm going to find the volume of this when I'm ready. And then after that, I'm going to convert this 1000 cm cube, I need to change this to, I need to change that to mm cube. I need to change it. Here's the conversion. So I'm going to have to work with 1 unit. So don't just run on with the question and run without looking. There are 2 different units going on. They gave me something in cm cube, but all my other measurements are in mm cube. So I'm going to convert that to mm cube. And then by then we're at the end of the rule. But firstly, you want to know the material that you need to use, right? So basically, I want to find the volume. Hold on. I'm going to have to find the volume of the disk first. And that is going to equal to the cross section area. And you want to multiply that by the thickness. So we're talking about 1350 times 2. And this is about 2,700 millimeter cube. So you see that? The disk is 2,700 millimeter cube. Now, I'm going to have to change this 1,000 centimeter cube to millimeter cube. But you were told that it takes 1,000 to make 1. Oh, therefore, I'm going to have to multiply 1,000 times 1,000. So because for every 1,000, it's 1. Oh, so if I get 1,000 of that, I have to go 1,000 times 1,000. So we're looking at 1 million mm cube. It's a million mm cube. So what I'm going to have to do now is that I want to divide this into the million to see how many I'll get, basically. So let's divide that into the million. So the number of this, there are more than 1 ways to work it in. So I'm taking it from this angle. I'm working with mm cube. The number of this, because the question wants to know the maximum number of this. It's going to equal to 1 million divided by 2,700. We could do that. And I'm getting a value of 370.37. But in reality, if you're making a CD, you can't have a 0.37 disk. So now you're going to have to think in context. What's the maximum amount I can make? I only can make 370. I will have some little leftovers, but you can't make another one. That's what we're talking about. So that's the answer. So even though you work it out and you get this, pay attention to the details of the question. You cannot submit 370.37 in this context. It will not be correct, because in context of what they want, the maximum number would have been a whole number, because we're making disk, right? So we can't have a half of this, or we can't have a third of it. All right, so there it is. So you would have found that, collected 3 marks. Let's see what else they're asking. Oh, it's another question. All right, so we're done with the disk question. Now, another question here says, so watch this now. It says a globe is a scaled spherical representation of the Earth. The actual length of the equator from L to L is 40, right? 40,000 kilometers. And it is represented by a piece of string of 160 centimeters. Oh, all right. So we're talking about dealing with the map, like dealing with the globe, using a string on the little globe and what it really means in reality. Question says, what length of string would represent an actual distance of 500 kilometers on the globe? I would want to scale this down first, right? I would say 160 centimeter from my globe is equal to 40,000 kilometer actually. Or you could just say actual. Let's use actual, no adjective. Right? So then 1 centimeter is a divide. 1 centimeter is to show, I'm going to divide this by 160. So I have the link between 1 centimeter on the globe to actual. 40,000 divided by 160. And it's going to show you that 1 centimeter would represent 250 kilometers in reality. 1 centimeter is 250 kilometers in reality. I know that. So now that I know that 500, you could see it's 2, right? So then 500 km is equal to, and it's going to give you 2 centimeters. So remember, for every 1 centimeter, there is 250. So if you reach 500, you would have just reached 2 centimeters. I'm just showing the working for it. We divide it and you go. All right, 1 mark, easy cheese. Just breaking it down so that you could see what's going on. The next question says this. Next question says, the distance between Palmyra, P, and Quintet is represented on the globe by a string of 25. So this is the globe now. And on the globe is 25 centimeters. Calculate the value of PQ, the actual distance in kilometers, the actual distance. The actual distance. Remember now, 1 cm would have given 250 km. So what I'm going to do now, though, is just to multiply. I'm going to multiply 25 by the 250. Because for every 1, it's 250. So 25 times 250 is going to give me about 625 with a 0 kilometers. Because for every 1, it's 250. So if I have 25, it's going to be 25 times 250. This is the actual distance. Actual distance PQ. All right. All right, let's just attack the final one. Let's go up to question 5. Starts here, yeah. All right, nice one. Question 5. All right, let's go. So question 5 says, students in a group were asked to name their favorite sport. Their responses are shown on the pie chart below. Calculate the value of X. Right, calculate the value of X. So X, as you could see, calculate the value of X is the angle you want. But as you could see, there's 360 degrees in a circle. We got 94, we got 45. So if I take those from my 360, whatever I'm left with would have been this. So we have 221 degrees. We're utilizing up the circle idea there. Let's go for the next question. What percentage of the students chose cricket? Look for cricket. Cricket is 94 out of 360. So we can simply move from fraction, which is 94 out of the 360, and then represent it as a percentage, fraction to percentage. So it's 94 divided by 360, multiplied by 100, and I'm getting about 26.1%. Very straightforward. Relate the idea as a fraction, and then do what you have to do with it as a percentage, which is to multiply by 100 all the time. Let's see what the next question says. A lot of 1 mark they're giving us. Given that 40 students chose tennis, calculate the total number of students in the group. 40 chose tennis, 40. 40 chose tennis. See there? 40 students. So there are 2 ways you can do this. Let's go down there and take a look at it. 40. Now, I could say to you, 45 degrees, that's tennis. This same amount is 40 students. I could use percentage and then relate it. One way you could have done it is to say, but 45 out of 360 times 100 will tell me the percentage that is 40. We can look at it like that. So I could find the percentage for tennis. I'm just saying that's just an approach. And this is 12.5%. So I think that's the answer. It looks like 320. 12.5% is 40. So this is telling me that 12.5% is equal to 40 students. I can use this and just go to the answer. All I have to do is to divide by 12.5 and multiply by 100 and it's finished. So depending on how I want to go, right? So I could say 1%, so I'm just going to use the teaching method. I could say 1% is 40 divided by this, and we're going to get 3.2, which means 100%, which is the entire group, is 3.2 times 100, and that is 320 students. That's just an approach. That's one approach, right? But I never had to do it like that. That's solution 1. Solution 2. I could now take my 45 degrees and say 1 degree. Watch this. I could just go 1 degree is to say 40 divided by 45. That's 1 degree. And if I multiply this by 360 now to get the full 360 degrees, because remember, if I divide the 45 into the 40, I'm going to get 1 degree. But if I want 360 degrees, which is total number, try that. 40 divided by 45 times 360, and I'm getting the same answer. I am saying in the exam, you will have multiple ways. I am not here to tell you what to do. Work on it based on how you feel. But there are a number of approaches you could get there. Get there if you can. EJ, if you want to study going, I'm going to do the question first. Soon. The B part says the diagram below shows the frequency polygon of the number, shows a frequency polygon of number of goals scored by a football team in 25 matches. Okay. All right, so we're seeing the number of matches, which is the frequency, and the number of goals here. All right. All right, let us look. They're giving us a table. Yes, they did. Complete the following table using the information in the diagram. So they have two missing spots. Could fill them out quickly. All right, two missing spots here. All right. All right, so one of the missing spot is that where the 2 is, which is the score. We want to see what match linked to that. 2 linked to 3. So you could see 2 here from the score, goal score is linked to 3. That's 3. Another thing, 5, which is here, links to 2. 5 links to 2. So you could simply just follow, same table reading and everything, same idea. Pick up your things, man. 5 linked to the 2, and you complete the table. Is 1 mark for it. All right, the answer is right there. You're looking at it. The modal number of goals scored. Please be advised. Remember, the frequency is not the data. It's how many times a certain data was seen. So we have to pay attention to the fact that we're looking at the F to help us to find the answer. The modal goal scored. Goals, so your answer must be goals. So you're gonna go now and look for the biggest frequency. Number 7.
1.
What's the modal number of goals scored? Very good, Leon. 1. 1. 1 is the answer. So the modal number of goals scored is 1. Right? So we saw 1 7 times. Let's go to another question. Determine the median number of goals scored. Remember, we learned how to determine the median already. Find the position of the median. It's 25 matches we were told. All right, so you don't need to add up to get 25. It's 25 matches. All right. Now we want to locate the position of the median by saying 25 plus 1 over 2. And it's going to help us. That's about 13. It's going to help us to get a number that can help us to locate where the median lies. So in blue, we're going to count from left to right and then right to left. Let's go left to right. We're going to keep adding, do a cumulative check until we reach or pass 13. 5 plus 7, not 13 yet. But by the time we add 3, right here.
2.
All right. But we're not going to pick the answer yet. You're going to have to go the other direction. Come. 1 plus 2, that's 3. Plus 4, that's 7. Plus 3, that's 10. And by the time you add this, you reach same place. So the answer is 2.
2.
Remember now, the frequency is not the answer. The frequency will help you to locate the number of goals scored. Very good. So the answer is 2. All right. So we have that done. Calculate the mean number of goals scored. Mean. I think this is the last. All right, good. Mean. Let's go to the table. Where's the table, guys? Hold on. Oh, right here. The mean number of goals scored. Let me kind of clean up the table a little bit.
Mean. Mean is sum f of x over sum of f.
Yes. So I'm going to put it on top. All right, guys, we're just going to do it on top right here. So we're going to put the fx on top. So then, follow me now. Or we could put it underneath. Let me put it underneath. We have more space. Fx column here. So here we're going to put a number there, put a number there, put a number there, put the number there. Let me clear this off. Then I put the numbers right below it, right below it. So it's like I create an extra column here for that. Like something like that. So then 0 times 5 is 0. Agree? This is f, this is x. Let's multiply. 5 times 0, 0. 1 times 7, 7. 3 times 2, 6. 3 times 3, 9. 4 times 4, 16. 2 times 5, 10. 1 times 6, 6. All right. So we want to find the total for that. Can remember that the mean is the sum of the fx over the sum of f. So let's add up all those fx.
54.
How much you got?
54.
54. And let me put it at the end right here. It's 54. So this is going to be 54 over how many? 25. 54 divided by 25. And we're getting 2.16.
2.16.
But was there a specific instruction or not? Calculate the mean, not necessarily. So let me just write it down here. So it was a 54 over 25, and we get 2.16. There it is. So that's the amount of goals scored. Okay. All right, guys, we're at the end. I'm going to stop there. So we did from question 10 all the way back to question 5, I believe. All right, that's a good workout. All right. I'm going to come on tomorrow. I'll post the time. Look out for it. You could come on tomorrow, and then we could work some math. I'll send out the time. Check the channel. Check the YouTube channel so you could see the time that I'll be coming out tomorrow, which is just the final warm-up for the exam, which will be on Wednesday. All right, guys? So take care of yourself. And it was nice having you guys online here.